Good morning, 7th graders. Good morning, Algebra world. Okay, we are going to do something that we've looked at before. Early in the year, we did a bunch of graphs, right, where we graphed all of those graphs using a table of values. Okay, so we're going to use that idea today and add a little bit to it. Okay, so this is graphing parabolas. Every one that you graph is a parabola, and they will all have about the same shape. All right. So let's take a look at a couple of examples. I've got this parabola here, y equals x squared plus 2x minus 3. This is a quadratic function. A y equals, right? So we can put it on an xy coordinate plane. Y equals x squared plus 2x minus 3. And so if I start making a table of values and I just plug in the x's wherever there's an x, then I find that where x equals 0, y equals negative 3, right? I plug the x in here, and the x in there, 0 in there, so that makes these zeros, and that's negative 3. So I plugged in a couple of values here. I plugged in several values to find out what this function looks like. I always start with 0. And so I plugged in 0, and I found out that it's negative 3, and I plugged in 1. I don't know why I jumped over where x equals 0. Sorry, I found it's negative 3. So I plugged in 1, and I found that it was 0. And I plugged in negative 1. I do everything kind of on either side of 0 and find out where it goes. And I found out that it was negative 4 right down here. So it seemed like this was going this way. So I plugged in negative 2 and found that it goes back up because I know the shape of a parabola. So I can follow that shape as I'm choosing the values to plug in. Okay, so hopefully you can, if you want to pause that and take a look at my set of values, and you recall that we're going to plug into just the x with parentheses, right? So there's another concept that's going to come up on the pages that I've given you. It's the 9-1 study guide. And it's this idea that there's an axis of symmetry. So right down the middle of a parabola is an axis of symmetry. So it is equal, exactly the same on either side of that axis. If we think of this equation as y equals ax squared plus bx plus c, then a here is an invisible 1. A is the coefficient. B is this positive 2. And c is negative 3. Okay? So if I come up here, I can, if you actually read the study guides, then you'll see this written there, that the axis of symmetry is this equation, x equals negative b over 2a. I'll say that again, x equals negative b over 2a is the axis of symmetry. So I plug in negative b, so I've got a 2 here is b, positive 2, so I plugged in negative, parentheses, b, over 2 times a, which is 1, okay? And I found that negative 2 over 2 is negative 1. And look at that. That matches up. That axis of symmetry matches up with my graphed parabola from my table of values. Okay, let's take a look here at this other concept. So functions have a maximum value and a minimum value sometimes, especially if they come back and they go back up, they come down, they go back up. Then this is called, this vertex down here is called a minimum value. This is the lowest y value of this equation, of this function, of this graph. It's the lowest. Okay? This one that I'm doing over here has a maximum value. So because it opens down, it has a maximum value, and so this is the highest y value of this function. Okay? All right. I believe that the problems ask you for the domain and range. Domain means what x values can I plug in? So domain is about the x values. I could plug any x's into here, any x's at all. Right? So it could be negative 1 million and it would plug in here and there is no limitation on that. It could be positive 47.3. I could plug that in. So the domain is all real numbers that can be plugged into x. The range here is all of the y values that will come out of it. Well, we can see that the range here is all y values that are greater than or equal to -4. So it's y is greater than or equal to -4. That's the range of this function. Okay, let's take a look at this one. I've got y equals -x squared minus x plus 2. Okay, y equals -x squared minus x plus 2. I can look at a table of values. I plugged in 0 and I found out that where x equals 0, y equals 2, right? I plugged in x equals 1 and I found y equals 0. I plugged in y equals 2. It looked like it might be going down this way. I found out that x equals I plugged in x equals 2 and got y equals -4. This seemed to be curving in, so I just went back over here, -1. I plugged in -2 and -3, all right? On my funny board here, I came up and I said, let's just check this axis of symmetry. The axis of symmetry, again, is x equals -b over 2a. And so I plugged in -b, which is, there's an invisible 1 there, so -1 over 2 times -1, so negative, and that equals 1 over -2, or -1/2. And look at that, it matches up with what my table of values showed. These little points here at the ends are called the vertices, or this is the vertex. This is a maximum value because it's the highest y that can occur. And the domain of this function is that I can plug in any x's I want, and so at all real numbers is the domain, that the x's can be any number at all. And the range here, I could find this out, the range, if I plug in -1, and I'm not going to do that right now, but the range is whatever this y value is right here, which actually is 2 1/4. I know that is 2 1/4. Then all numbers less than or equal to 2 1/4. Okay? So this is our introduction to graphing parabolas. Good luck. Give it a shot. I'll talk to you soon.